Hi, I want to talk about one of the poor misunderstood forces in physics, the contact force known as the normal force. And the normal force is a more scientific name for the force of touching. Anytime two objects touch each other, if we go down to a microscopic level, what we would see are atoms all linked together. As the two surfaces start to get closer and closer together, there's repulsion between those two surfaces, trying to keep everything apart. Well, what ends up happening in the macroscopic world is that along this line of contact, there's a force felt by each of the objects touching. So here, the stick figure is leaning against a board. So if I were to zoom in, I have the hand and I have the wall that board is attached to. Those two are the two objects that are interacting in that force. And remember, every force is an interaction between two objects. So whatever two objects are touching, those are the objects subject to our normal force. Now, the reason why it's called the normal force is because that force is experienced perpendicular to the line of contact. And in math, perpendicular is called normal. So we could have called it the perpendicular force instead of the normal force, but we call it the normal force. Now, as a symbol, we'd use a capital F and a subscript n. Of course, it's a vector because it's a force. As one way that we could represent the normal force, some textbooks will use a lowercase n and a vector harpoon over it as their representation for normal force. So whatever mnemonic works for you for understanding that force, go with that. So if I have a hand and a wall touching each other, since those are the two objects involved in that normal force, then we have two ways that we could view that interaction. And the way that Newton's third law is really sort of telling us what to do in this situation is to consider our object of interest and draw our free body diagram as that force acts on our object of interest. So if our object of interest is the wall, and what's going to happen when the stick figure is leaning against the wall, well, I would draw that force as it acts on the wall. So between the touch of the hand and the wall feels the hand pushing it to the right. If my object of interest, though, was the hand and not the wall, then I would draw my force picture for the hand the exact opposite direction. My normal force is because the wall is pushing the hand to the left. Now, these aren't two forces. This isn't an action-reaction, because those really aren't a thing. It's an interaction. And the interaction is saying, when we care about the wall, this is how we draw it. When we care about the hand, this is how we draw it. And if we care about what's going on in the entire room around us, where both that hand and that wall happen to be internal to what we're looking at, then Newton's third law says it doesn't matter, because that's an internal force and not an external force. So, just to recap important pieces. Normal force, all the word normal means perpendicular. Touch is always experienced perpendicular to the line of contact. And whenever we evaluate it, we always draw the touch based off of what our object of interest is. What do we want to figure out is experiencing a force? Draw our normal force from that perspective, and then we can use it in our Newton's second law calculations to determine what sort of acceleration we might have. Thanks for watching.